All right, today we are going to start our new unit and we are going to be doing transformations. And so we are going to translate figures today. And it says and use vectors, but we are not going to use vectors today. So we're going to go through this vocabulary, and remember that you can pause the video at any time if you need more time to write something down, or you can go back to something if you need to hear it again. So a translation moves every point the same distance in the same direction. So it can be thought of as like you're sliding something. So it's all going to stay the same size. You're just moving everything in the plane. So that's a translation. Our notation, coordinate notation for that, we are going to have each XY coordinate is going to move A units to the right and B units up. And this can be right or left or left. So it'll be a positive if you're going right, negative if you're going left, and this is up or down. Positive if I'm going up, negative if I'm going down. The image is the new figure that's produced from the transformation of another figure. So when I move my figure, say it's my triangle, when I move it to a new location, that's called the image. The pre-image is your original figure. So pre means before. That's the original figure in the transformation of a figure. And then an isometry is a transformation that preserves length and angle measure. So when I move this figure, it's not going to change shape. It's going to stay the same size. And that's what the translation theorem says, is a translation is an isometry. So we are going to do an example now. So first we need to graph all of the points that are listed there, and then we are going to do our translation. So graph your vertices A, B, C, and D. And again, you can pause the video at any time. So A is -2 up 6. B is 2, 4. C is 2, 1. And D is -2, 3. Okay, so there are my, there's my original figure. Now, when I want to translate that, I'm going to use this notation here, okay? So I can either go and try to figure out what my new coordinates are going to be, or I can count in a certain direction. So again, remember when I see x plus 3, that means that I am going to be moving to the right 3, and the -3 for y minus 3, that's going to be down 3. So I can go to each point and count right 3 and down 3, or I can plug in each x coordinate. So for example, if I want to find a prime, I would plug in -2 plus 3 and 6 minus 3. So a prime is 1, 3. So we call them prime when that's our image point. So I found that by plugging in the -2 and the 6 in here for the x's and the y's. So I'm going to erase that again. Or I could have counted from A, I could have counted right 3, 1, 2, 3, and down 3, 1, 2, 3. So that's our A prime, which is 1, 3, up 1 over, or right 1, up 3. And so you can go ahead and do the same thing with all the other coordinates. You can pick which way you want to do that by plugging them in, x and y, or by counting. So B, I'm going to count right 3, 1, 2, 3, down 1, 2, 3. So B prime, and that coordinate is 1, 2, 3, 4, 5, up 1. So B prime is 5, 1. And again, I could have gotten that by taking 2 plus 3, which is 5, and 4 minus 3, which is 1. C prime, doing it the other way, 2 plus 3 is 5, 1 minus 3 is negative 2. And that would be over here, so 5, negative 2, C prime. And then D prime, negative 2 plus 3 is 1, and 3 minus 3 is 0. So 1, 0 is where D prime is. And then we usually use a dotted or a dashed line for that image. Now, you don't have to use two different colors. Sometimes it helps just so that you can see a little bit more clearly which one is the pre-image and which one is the image. But this is how you would go about translating a figure. So again, you can either plug it into X and Y, or you can count right 3 and down 3 for every point. So if I look at my coordinates, they've all moved right 3 and down 3. So 1, 2, 3, 1, 2, 3. All right, next example. Okay, so we are going to write a rule for the translation. So now we are going to write the XY arrow part. So it should be in this form. Okay. So we're going to look at the figure. Remember, the original figure is the solid shape, and then the translated figure, the image, is the dashed, and it has the primes. So again, notice that this is going by 2's. So if I want to figure out what the translation is, I need to figure out how I go from C to C prime, or from A to A prime, or from B to B prime. So if I count, if this is going over 2, this is halfway in between, so that's going to be right 3, and then down 1, 2. So I'm going right 3 and down 2. So right means plus, down is subtraction. So that would be my rule for the translation. So X plus 3, Y minus 2.
Ken Anderson, please come to the activity.
And our last example, this one we are going to find a point on the pre-image if the point on the image is 3, 5, after this translation of X minus 8, Y plus 1. So we are trying to go the backwards way this time. So the rule always tells us how to get to the image. And so we move our points, in this case, left 8 and up 1. Now we're going to go the opposite way. So we want to figure out how we got to 3, 5. So essentially, 3, 5 is, 3 is what results after I take X minus 8. So whatever my X is, I get a 3. So X plus 8, or I'm going to add 8, so I have X is equal to 11. And doing the same thing with Y, after I did Y plus 1, I would get 5. So Y, I'm going to subtract 1, gives me 4. So if I have the point 11, 4 as my original point, if I plug in X is 11, 11 minus 8 is 3. And if I plug in 4 for Y, 4 plus 1 is 5. So this is my pre-image, the one that came before the image point. This is my image, 3, 5 is my image. So just think of it as going the opposite way. So instead of subtracting 8 and adding 1, you're adding 8 and subtracting 1. So pay attention on your homework for if it's looking for the pre-image, you do it the opposite way because you're going the opposite direction. Again, help each other out, and don't be afraid to ask questions.